Okay, thank you for having me here. So I'm Ville Tulkki. I come from VTT Technical Research Center of Finland, which provides all kind of insights when it comes to technology. Here I'm to describe small modular reactors for you in case that there is still somebody in the audience who doesn't know what small modular reactors are, and also some thoughts about how they can be used in heat production, especially on district heating. So thank you, Janne, for introduction into the topic. I will be going on what they are, what's some small description of global picture. We will be hearing a lot more from the vendors today, and then also what's the case for SMRs. So basically, the SMR comes from small modular reactors. Small, well, it's in the quotes because by definition 300 megawatts electric or below, so they are still large industrial facilities. There are some microreactors, but usually when we are talking about small modular reactors, it's still industrial facility. It's not going to fit in your garage. Modular idea with this is that they should be factory produced so that you can actually produce several manufacture several instead of constructing like in the current power plants. Not all of these SMRs are actually modular, especially some heating reactors, but this is still part of the term. And they are nuclear reactors, which brings all the baggage that it has. So there is a huge variety of designs, tens, even maybe hundreds of different designs at different stages. Reactor size, what they use as a coolant, what they use as a fuel varies. So it's a huge umbrella term, which when we are discussing SMRs and their use, we should always be able to define what kind of SMR we are talking about, what use. But big question, of course, when we are developing a new technology is why we actually want to develop. Because, okay, science and technology is fun. I'm a scientist. I love to do these things. But if we actually want to build new infrastructure, there needs to be a very good reason. For nuclear power, the traditional idea is the economies of scale. So the bigger unit you build, the cheaper the electricity or energy will come. But especially in the West, we have seen that it has become a bit difficult to build large reactors, like we saw from Janne's slide from Lazard in the US. The costs have gone up for various reasons. One of the idea or driving forces behind SMRs is the idea that when you start to serial produce these reactors, you can get smaller reactors in cheaper thanks to the economies of volume production. But this is something that we will still remains to see whether this can actually happen. Other ideas or driving forces behind SMRs is that basically if you're doing smaller systems, the smaller size just enables achieving the required level of safety with easier or simpler systems. There are innovative solutions. For instance, this kind of integral PV pressurized pressure vessel that we will be hearing a lot later today will actually remove the danger of large break loci, and also new reactor technologies like molten salt reactors, which might decrease the cost. But other thing with the SMRs is the wider application range. Traditionally, nuclear power has been used to produce electricity. SMRs can do that. They can also provide grid support, but also heat uses, like district heat, desalination, industrial process heat, and potentially hydrogen production could be the niches that the SMRs are especially suitable for. Especially when it comes to the heat production. Well, heat it's hard to transfer, so it needs to be produced quite close to the location of use. It's also limited in scale. So, for instance, if we are looking at currently in Finland, the nuclear power plants currently in, being built or being commissioned in Finland, they have heat capacity of 4 to 5 gigawatts of heat, and there is no use for that much of heat in one place. As we heard, there's also very few other low C options for production of heat. Also, these lower temperatures, like district heating, they require lower pressures and can be produced with lighter components. So there is a distinct breed of reactors, also these district heating reactors. When it comes to global situation, what's happening with SMRs? They are being developed in very many places. This is just a few examples. Unfortunately, I did not have everybody present here on this, but they will tell about their own SMRs. But for instance, in Canada, Canadian Nuclear Laboratories aims to be the SMR technology hub. There are many projects in the pre-licensing pipeline. In the United States, of course, NuScale is under licensing process with several other projects going on. And in United Kingdom, there is an advanced modular reactor project going on with also this SMR project ongoing. France just announced that they are going to do an SMR with the French components for international markets. Russia has barge reactors. China has very many different kinds of reactors, SMRs in design, and also in South Korea, the smart light water SMR. So there's lots of different reactor designs in the pipeline. But what's the case for Finland? I think that this is something that will be repeated quite many times by Finnish speakers. So electricity is already here, quite low C, and it's getting cleaner thanks to the new nuclear power plants, more wind power coming online. However, if you look at individual emitters of CO2, we can still say that there are some very challenging situations when it comes to steel industry, refineries, large cities, also other industrial factories. All of these actors reduce their emissions in various ways, but producing lots of heat in a small, dense place is challenging. So nuclear could actually help here. This is not just a Finnish challenge. We are just a bit ahead of the rest because our electricity production is already quite clean. Residential and industrial heat will be an issue everywhere. They are just not talking about it. So also the issue with the heat is that it needs to be produced locally, and there is also different temperatures that are needed. You cannot heat your home with the temperature you use to melt steel, I hope. Anyway, so here's European heat consumption put into different slots based on temperature range. So scale here is Finnish annual electricity use. So low temperature between 100 to 250. Heating of buildings, paper mills, such as that, is basically 8 Finnish annual electricity uses. This could be served with light water technology. Light water reactors that are currently already in use. Bit higher, 2050, 550, chemical industry, refineries. This is something that high temperature reactors could serve. And then we have the very high temperature applications, production of steel, cement, glass, so on. We probably cannot have a nuclear reactor that would produce heat about 1000 C range, but that's basically forming first hydrogen and using that hydrogen as energy source, as a clean energy source. So this is basically how different nuclear technologies could serve to help with different kinds of uses. So we are here talking about district heating. So, well, ongoing discussion how to clean up emissions from district heating. Using nuclear is actually not new. In the world, there's about 50 nuclear reactors that supply also some heat to nearby communities. So they're CHP plants. And there have been plans for heat-only reactors in the 70s, 80s. This is a picture of secure reactor that was designed by Swedish and Finnish collaboration in the 70s. It's basically the idea that because they require lower temperatures, lower pressures, and less demanding conditions, so the safety would be easier to assure, and it would be easier to manufacture these lighter components. So in that sense, heat-only reactors could be one of the future niches in places where there are district heating networks. We at VTT have done some techno-economic studies on integration of nuclear heat supply to district heating network. Finally, we managed to get the paper out. It came out yesterday, so very timely. The big issue is that the summer demand is quite low, so it limits the amount of nuclear heat that could be done summer, but in principle, capital area might have reasonable heat demand for several hundreds of megawatt reactors. And these basically economics compete with high efficiency heat pumps, which on the other hand might have difficulties finding enough heat sources. This is basically the situation. Here is the heat demand, and this is like simulation with the two heat-only reactors, which might be cheaper solution, but their technological integration into the system at this scale might be problematic. And on the other hand, if we would have several smaller combined heat and power reactors, they could help to produce electricity when the electricity is expensive and producing heat when electricity is cheap. And also having several smaller reactors would help to have this low summer demand, in the sense that these yearly maintenances could be staggered to fit better the summer, during the summer. So, of course, there will be many challenges, such as integration of heat, technical challenges, integration of heat reactors into the systems and surroundings. Where can we locate these reactors? How do they fit within the regulation? Stakeholder awareness. So do the potential users understand all the challenges? Do the nuclear side understand what's happening? What are the limitations? What are the possibilities? Also, currently, people would very much like to have a ready reactor off the shelf. It's not happening at the moment, of course. So, but what could we do to actually improve the situation? And of course, public awareness and acceptance. The discussion has only started, even in Finland. What we at VTT are doing to alleviate this, so we are now having ongoing project, call it Finnish actors in the domestic SMR ecosystem. So aim is to scope near-term potential for SMRs, heat for various users, looking also Finnish capabilities. Research partners, VTT, Lappeenranta University, in this future project looking for industrial partners also. So, and this aim is to pave way for future business for various actors. And also we have starting an European project towards European licensing of small modular reactors, coordinated by VTT and Fortum also in a big role there, aiming to start this summer. With 15 partners with strong collaboration with the developers of the French SMR design. So this is what SMRs are, how we could use it, and what's going on. Thank you. Finally, so to conclude, small modular reactors expand the use of nuclear energy and in many places complementary to large reactors and renewables, of course. There's various designs, but currently many of them are near the innovation death valley between proof of concept and commercialization, and would help a lot with future's hard challenges. Thank you.